If a battery or a source is connected to a conductor, electric current is produced in the conductor. But if a magnet is moved near a conductor or vice versa, then the electric current thus produced in the conductor is known as induced current, as it is induced by a magnet. Once induced current is set up or produced in a conductor, we must know two things. One, what is the magnitude or what are the factors on which the magnitude of induced current produced in the conductor depends. Number two, what is the direction of the induced current that is there in the conductor due to disturbed magnetic field. Before starting with the factors, let us refresh our information about electromagnetic induction. Electromagnetic induction is the phenomena of inducing electric current in a conductor by disturbing the field of a magnet. There are two methods of inducing electric current in a conductor. One, by relative motion between conductor and magnet. Look into the diagram that is there in the bottom left side. When a magnet and a coil made up of a conductor are set in relative motion with each other, induced current is produced in the conductor by a natural phenomena whose name is electromagnetic induction that was first observed by Michael Faraday. The second method of inducing electric current in a conductor is by without any relative motion. That means if there is no relative motion between conductor and magnet, then also induced current can be produced. For that purpose, we should have two solenoids. One of the solenoid to be connected to a source, and once circuit is closed, the solenoid connected to the source will be named as primary coil. Solenoid connected to a source, and when there is current in the solenoid, it will behave like a magnet. And the other solenoid will be connected to a galvanometer, which will read the slightest generation or production of electric current in it. So in the primary coil, when magnitude of current is varied by either switching on and off or by putting a rheostat and varying resistance and hence varying electric current. So when electric current is varied, then the magnetic field associated with a primary coil also varies. So more electric current results in more magnetic field or stronger field. Less electric current will result in mild field. And in this process, there will be a throw and withdraw of magnetic field. And in that disturbed magnetic field, if a conductor or a coil is just placed, induced current is produced in it. So these are the two ways, either set them in relative motion or put the conductor in a disturbed field for generating induced current in a coil. And in this process, we are not using any battery for producing electric current. We are using magnet for producing electric current. Now, the phenomena of electromagnetic induction was first given by Michael Faraday in the year 1831, and he called this phenomena as electromagnetic induction as electric current is induced by magnetic field. So there are three laws of electromagnetic induction. One of the law is whenever magnetic flux linking with a coil changes, that means magnetic flux changes, that means magnetic field is disturbed or cut by a conductor, or there is a throw and a recession of magnetic field due to varying current in the primary coil. So flux means the number of lines of forces of magnetic field per unit area. So whenever magnetic flux linking with a coil of a conductor changes, an EMF or induced current is produced in the coil, and EMF is induced in the coil, or electric current is induced in a coil. So it's a natural phenomena found by Faraday. The second law of Faraday is the magnitude of induced EMF or current. That means how much current will be produced. That depends upon that is directly proportional to the rate of change of flux. That means if there is a tremendous relative motion between magnet and the conductor, then if the relative motion is more, then there will be more disturbance of the field lines due to the conductor. As a result, more induced current is produced. And the third law of Faraday related to electromagnetic induction is the EMF or induced current depends upon number of turns of the coil. That means if there is a more number of turns which stands in a disturbed field or which cuts the field lines of a permanent magnet. So that is why straight conductors are not taken, coils are taken. So more number of coil or more number of turns of the coil cuts or disturbs the field of a magnet, then more induced current will be produced in the coil. So the magnitude of induced current depends upon one, relative motion. That means the magnet has to be in relative motion, then only the needle of the galvanometer will be seen deflecting, means current will be produced. If the magnet is stationary, no induced current in the coil. And the magnitude, that means more amount of current will be produced if there is more relative motion between the magnet and the coil. So the factors. So those were the Faraday's laws. Now these are factors on which magnitude of induced current depends. That means how much current is produced in a conductor depends upon what? Depends upon the first bit, the EMF or induced current lasts as long as there is relative motion. That means when there is a relative motion between magnet and coil, as long as it is there, there will be electric current in the conductor. If there is no relative motion between magnet and the coil, there will be no induced current. The second, the magnitude of induced current depends upon relative speed of a motion. That means the magnet and the coil has to be in good or tremendous speed with respect to each other for generation of more induced current. And the third one is the magnitude of EMF or induced current depends upon number of turns. That means more amount of a conductor cuts or remains in a disturbed field, more magnitude of induced current will be produced. So these are the three basic things on which the magnitude of induced current in a conductor depends. Moreover, the important point to be understood or noted related to the magnitude of induced current. When can we have maximum induced current produced in a conductor? When a magnet is moved near a conductor or vice versa. The magnitude of induced current will be maximum when the conductor is placed perpendicular to the direction of a magnetic field. That means when the conductor is placed perpendicular to the direction of magnetic field, it will be properly cutting or disturbing the field lines. As a result, there will be maximum generation of induced current in the conductor.